Algebra 2, we are going to be in lesson 8, and we've got kind of maybe a complicated lesson today, but I want to show you a couple of things. First of all, in lesson 8, the first part of lesson 8 talks about what a nomial is. And I'm just going to say that a nomial can be anything. It could be -4, a nomial could be x squared, a nomial could be square root of 20. If I said a binomial, that means I take two nomials and make them do something. So if I said -4 plus x squared, that would be a binomial. Now, can you do -4 plus x squared? Well, you actually can, but that's a little higher math, and so we're not going to worry about it right now. But that is a binomial. If I have a polynomial or a trinomial, I have all three. So I have a -4 plus x squared plus square root of 20 equals something. So all I'm trying to demonstrate is there is a designation for nomials and polynomials, and I just want you to be aware that those things actually do exist, okay? And you're going to be seeing these later on in our math, but the reason they bring that up is because of what the meat of this lesson is about. And the meat of the lesson has to do with graphing an equation. So, if you look at the bottom of page 53, example 8.1, there's an equation that's given. And the equation is this: 2x equals, or plus 3y, equals 6. How do we solve this? And we're going to do something with this graph over here that you see. So let's go step by step. First step is to solve for the y. So what we're going to do is we're going to subtract 2x from this side and subtract 2x from this side. So that y is left on the side of the equal sign. So we're going to take away that 2x and that 2x because we've moved it over here. So 3y now equals a -2x plus 6. Or you could say 3y equals 6 minus 2x. Now, when we deal with actual graphing, there's a certain order that is commonplace, okay? And it is this: y, oops, let me get rid of that. Y equals mx plus b. What does that mean? Well, we always solve for y. We want to know in the equation what y equals. M is going to be something called slope. B is the y-intercept. And we'll get to that in just a little bit. So let's go back to our equation. Okay, we had 2x plus 3y equals 6. All right, so we subtracted 2x from this side, we subtract 2x from this side, we ended up with 3y equals -2x plus 6. This is in the y equals mx plus b format. This is good. And this is what you want it to look like to start with. Okay, right here. Now, we're not done with this yet, okay? And it's going to take us quite a bit of time to finish that out, but at least we are on the starting gate. We're beginning to roll, okay? So we said now that 3y equals -2x plus 6. We got to get y to be equal, so we can do that. If we divide every single nomial by 3, then y can get by itself. Okay, you're like, how did we just get here? Well, 3 over 3y equals 1 over 1y, which is simply y. If we put this over 3, we have a negative 2 over 3x, and then 3 divided into 6 is 2. So now we can make a function box that will help us to answer what happens. So we'll call this x and y, and what we're going to do is we're going to say that when x is 0, y is something. When x is 6, y is something. And x is negative 6, then it's something. We could add more, but for right now, we'll just start with those three numbers. Why did I choose 6 and negative 6? Because your textbook did. You can choose 1 and negative 1 if you wanted to, or 2 and negative 2, or 3 and 5 if you wanted to. It doesn't matter what you do, but let's just do this for right now, okay? Let's go to this problem. So when y is 0, well, what does that mean? So let's do this. Let's go y equals negative 2 over 3 times 0 plus 2. Well, what does that mean? Well, 2 over 3 times 0, what does that equal? 2 over 3 times 0 is 0. Anything times 0 is 0. So y equals 0 plus 2. Y equals 2. So when x is 0, what we're saying, x is 0 right here, then y is a positive 2. Okay? Let's go to another segment of this. Let's make x 6 and see what we can do here. So y equals negative 2 over 3 times 6, positive 6, plus 2. So y is going to equal negative 12 over 3 plus 2, or y equals negative 4 plus 2, which means that when x is 6, y is negative 2. Well, if that's the case for negative 2, then of course the opposite is going to be true when this is negative, because that's going to be a positive 12, this is going to be a positive 4. So we're going to end up with a positive 6 here. Well, now we have coordinates. And coordinates are x and y in order. So we have x as our first one is x is 0, y is 2. Can we chart that? Can we chart this one right here? Yes, we can. So we have x and we have y. So x is this 0, which means it doesn't move, and y is 2, which means we go up 1, 2. We go to this positive 2. There's 1, there's 2. Okay, this is 1, 2, and so on. This is negative 1, negative 2, and so on. This is negative 1 and negative 2 and following. Okay, what's the next one? We have a 6 and negative 2. 6 on the x scale is 1, 2, 3, 4, 5, 6, and we go up 2. There it is. And we have negative 6 and 6. Well, negative 6 is negative 1, 2, 3, 4, 5, 6. And negative 6 and positive 6 is 1, 2, 3, 4, 5, 6. So it goes all the way up here. Okay, so we can chart all of those scenarios. Okay, so positive 6 and a negative 2. Oh, sorry, it's a negative 2. Forget that dot. I was going to say that's not lining up. And you'll notice that there is a straight line that coincides with this trio of coordinates. Okay, all of that to say there might be an easier way to do this. Okay, so start out with a coordinate system again, and we're going to do the same thing. Okay, we're going to put 2x plus 3y equals 6. All right, let's put this in the form again. So we subtracted 2x, we subtracted 2x. So here's what happens. We have 3y equals negative 2x plus 6. We divide by 3 every term. So we have y equals negative 2x plus 6. Okay, now I'm going to do something a little bit easier. 1, 2, 3, 4, 5, 6. This is called the slope-intercept method. Okay, I've got 6 tick marks all the way along. Okay, so when I find out what y is equal to, oops, 2 over 3, sorry. I'm going to start with this number, and that's going to go to my y-intercept. And that's because y equals mx plus b. We're going to start out with this one. This number and this number, same, which is going to be 1, 2, 3, 4, 5, 6. It's a positive 6. That's my first number. Now I'm going to look at this term. The top number is the rise. The bottom number is the run. Rise means whatever direction. If it's negative, then I'm going to go 1, 2. I'm going to come to this negative 2 down here. That's the rise. And the run is horizontal. So rise is vertical, whether up or down. If it's negative, it's down. If it's up, it's positive. Run is left to right. Okay? So over 3 positive. Well, 1, 2, this is positive 3. So here's my number. Well, get this. Again, I have this correlation. Wow, that was a bad line. Correlation, there we go, that's better, between those two lines. And that is my line. Okay, so I'm looking for that kind of answer. So when it says graph, you actually have to draw a graph and show me those examples. Okay, let's do the one in your text for this lesson. Okay, I know it's an odd, but let's do it anyway. Number 9 in your lesson, page 57, says graph, and then it gives us 3x plus 4y equals 8. Okay, let's put it in the proper form. Subtract 3x from this side, subtract 3x from this side. We're left with 4y equals negative 3x plus 8. We divide by 4 each term. We're left with y equals negative 3 over 4x, or rise over run, plus 2, because 8 divided by 4 is equal to 2. Now we can graph that. Y equals negative 3/4 x plus 2. Easy. Let's do slope-intercept method. Okay? We're going to start with our first number, which is positive 2. We're going to go on the y-axis and go up 1, 2. That's our first dot. We just finished that. Now we can do rise, which is a negative 3, which means that we're going to go 1, 2, 3 down here. That's a negative 3. And run is a positive 4, which means it's going to be in the right direction. 1, 2, 3, 4. There it is. Okay? So when we do that, okay, get a straight edge, because it's not going to be perfect here, it's going to be a line that looks and intercepts both of those points. Okay? And you'll get a nice ruler. In fact, I can bring this ruler over here and tip it on, maybe. Okay, there's a better line, right? So it's intersecting those points. Okay, so that's how you do your lesson. That's how you do your graphing, and you'll need to do that from now on.